Use the properties of logarithms to rewrite the following expressions as the sum or difference of logarithms. So the different properties of logarithms that we have, I could list them or just say, refer to your notes. You should have them readily available at this point. The most important ones that we would use for this topic is the rule that tells us that the sum of two logarithms of the same base can be written as a single logarithm where the arguments are multiplied, or if you have the difference of two logarithms of the same base, you can combine that by dividing the arguments. And then there's a third one which tells us that we can take any exponents on the arguments of our logarithms and make those constant multipliers. So these are the rules that we use for such. And what we want to do is rewrite these in as many logarithms as we can. And we're really just practicing with these concepts. So in part A, when I have log base 2 of 6x over y, the first thing that I notice is that division sign. And because we're expanding logarithms, that tells me what I could do to begin is to write this as the difference of two logarithms that have the same base. Okay, now the next thing that I notice here is that the first term is log base 2 of 6 times x. And anytime I have two things multiplied inside of the argument of a logarithm, that tells me I can expand that into two logarithms that are added together. Now, there aren't any other added terms or divided terms, and there aren't any exponents on these arguments. So this is as far as I can take this one. Okay, for part B, I have log base 2 of the square root of 5r to the third divided by z to the fifth. Now there's probably a lot of different places that I could begin this process. What I'm going to do first is change this square root into an exponent. So I'm going to write this as log base 2 of 5r to the third divided by z to the fifth, all raised to the 1/2 power. What that allows me to do is take this exponent that's on the argument of the logarithm and pull that out front as a constant multiplier, so that I could write this as 1/2 log base 2 of 5r to the third over z to the fifth. All right, and that's already simpler. The next thing that I can do is, noticing that division bar, is I could split this up into two logarithms. But I need to be careful and still keep this 1/2 multiplying both of those. So I'm going to put some brackets on the outside just to indicate that both the logarithms on the inside are multiplied by that 1/2. And brackets sort of make some students a little bit nervous because they think that maybe it means something different than parentheses. They absolutely don't. They mean the exact same thing as parentheses. The only reason we use brackets instead of parentheses sometimes is just to make sure it's very evident when you have a set of parentheses and a set, well, let's just say multiple sets of parentheses. It's very evident as to which ones go with which. That's all. Okay, so then the first term here has two things multiplied. So the next thing I could do is split those up into two logarithms that are added. So this would be log base 2 of 5 plus log base 2 of r to the third minus log base 2 of z to the fifth. And the last thing that I can do is I have these remaining exponents on some of the terms, and just like with the 1/2 at the beginning of this problem, I can bring these out as constant multipliers. So I could write this as 1/2 times log base 2 of 5 plus 3 log base 2 of r minus 5 log base 2 of z. Now, at this point, I honestly could distribute the 1/2 into the parentheses, or I could leave that outside, or I should say the brackets, sorry. But it doesn't really matter. I don't think it's going to be any simpler either way. So I'm just going to leave it as is in this case. Last up, in part C, I have log base 3, the square root of x times the cube root of y over w squared square root of z. And that looks a little bit like a 2, so let's do that. Okay, so to break this up, first thing that I notice is this division. So I'm going to start off splitting this up into two logarithms where the logarithms are subtracted, one for the numerator, and I'm going to go ahead and make a change here as well. So instead of saying the square root of x, I'm going to make this x to the 1/2 power. And then instead of saying the cube root of y, I'm going to change this to be 1/3 power. And minus log base 3 of the denominator, which is w squared, times z to the 1/2 instead of the square root of z. Okay, next up here, what I'm going to do is split the remaining logarithms up based off of the two terms that are multiplied inside the arguments. So that would give me two logarithms that are added. So this would be log base 3 of x to the 1/2 plus log base 3 of y to the 1/3 minus, and it's still subtracting this whole entire logarithm here. So I need to put this in brackets here and then say it's log base 3 of w squared plus log base 3 of z to the 1/2. Okay, and that's an important step because I need to make sure both of these two logarithms are subtracted, because if it's not, then I'm actually moving one into the numerator that shouldn't be in the numerator. All these terms here should be in the denominator. Now, the last step that I can do here is just take all of these exponents and pull them out as constant multipliers on these logarithms. So I would have 1/2 log base 3 of x plus 1/3 log base 3 of y. I'm going to let this negative distribute as well. So it's going to be minus 2, so the 2 comes down, log base 3 of w minus, because the negative is distributing, 1/2 log base 3 of z. And that's as much as we could expand that out.